going to talk right now about a DC circuit. I need the battery, I need the cables for positive and negative, and I need a switch to interrupt the flow of current, and probably I need a fuse to protect the load that I am going to install, and that's it. That's the only that I need. All right, this is a series circuit. This is the battery. Suppose that this is the battery. This is 12 volts. The battery have a negative terminal and a positive terminal. Normally the positive is indicated with red color, no? The positive is red. And after that I have a fuse, and after that I have the load. If you check the light bulb, let me bring a light bulb and I show to you something. When you have a light bulb, always, 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 in the bottom is the positive, and the case here is the negative. Yeah? Positive here and negative here. In the future, if it's for AC current, here is the hot line and this one is the neutral. Ready? In this particular case for DC, that's the positive cable, the red cable enter here, and the negative is going from the case. Everybody follow me? It's clear, my friends? Okay. The positive, my friends, enter in the positive side of the light bulb, and I am going to connect two light bulbs in series. You remember when we connect the batteries in series? What happened with the positive of the first one?
Going to the negative.
With the negative of the second one. Okay. The negative of the first one will be connected with the positive of the second one. And this is the cross cable, no? And after that, the negative of the second one go to the ground. This ground and this ground is the same. When I mark ground in the circuit, is the ground bus bar. In this particular case, the negative bus bar. Anybody follow me? And the circuit is complete. What about the voltage and the intensity and the resistance in those series circuits? What about the total voltage in that circuit, in series? Increase. Is the voltage number 1 plus number voltage 2, but all the series. The voltage goes
Higher.
up. What about the intensity? What about exactly? The intensity is equal to intensity number 1, intensity number 2, and this is the total intensity. Is constant. Is constant. This is the secret in the future when we solve it series and parallel circuits. And what about the total resistance in that series circuit? This is series. What about the total resistance? The total resistance, this is resistor number 1 and this is resistor number 2. What about the total?
Go down.
You add it. You add it. You add it. That's okay? This is the secret. This is the secret when you solve a series circuit. And this is the key. The intensity is
The same.
constant. It's the same. The intensity in series is constant. It's the same. This is the advantage when you connect series in circuit. When you connect elements in series. Suppose that I connect other one additional here. And once again, and this one is the ground. I have three loads connected in series. What is the disadvantage of that circuit? What happens if, for some reasons, this light bulb is broken? The rest of the circuit is broken. That's good? That's not good. This is you remember the Christmas light? If one of the light is broken, all the series, you remember? Garbage. Because it's difficult to find in 1 million of light bulbs, what is the light bulb broken? What is the advantage of series circuit? What is the advantage? The intensity of all of the lights is the same. This is the advantage. The flow of current is equal. It's the same in the circuit, in the entire circuit. Don't forget that, my friend. This is the advantage of series circuit. The intensity, the flow of current is constant. I need that all of those pumps connected in series receive the same amount of current. I need series. No? Other advantage of the series connection, you remember when you connect batteries in series, what is the element that increase? The voltage. Ah, okay. What happened in the morning with the engine of your car, of your boat? You want high voltage during the cranking. Immediately the engine starts, no problem. But you need in that moment high voltage. For that reason, normally for cranking purposes, you connect the batteries in series. Good?
Yep.
All right. And now we are going to check the same connection in parallel. Okay. What about, it's exactly the same, no guys? This is the battery, this is the total voltage, it's 12. This is the fuse, this is the switch, the interrupter, the Garfield. Those are the loads, and this is the return to the ground. My friend, be careful with the return. Be careful with this one. The majority of the problems, practically 90% of the problems that I receive every day, phone calls related with electricity, is no ground, no return. Hey, my friend, oh yeah, Mr. Lopez, the ground is disconnected. No ground, no return. Be careful with the ground. The people connect the positives and forget the negative. Okay? Always, 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 before you start, check if my ground is properly connected. Okay, we are going to check what happened in this parallel circuit. What happened with the voltage? Look, the voltage here, here, and here should be, if I check voltage, normally when I check voltage in between the positive and the negative. Yes or not? If this is the voltage of the battery, 12 volts, in between the positive and the negative, I have 12 volts, no? In between this positive and this negative is the same, I have 12. 12. 12. 12. Ah, the voltage in parallel is constant. It's the same. Ah, that's the most important part. In voltage, in parallel, when I connect batteries in parallel, circuits in parallel, the voltage is constant. What about the intensity in that parallel circuit?
It increased.
The intensity is going?
Increased.
It's going up. Increase. Ah, the tricky question is, what about the resistance in a parallel? It's the opposite. You see? The resistance decrease. Right now we are going to talk and we are going to check an example. Oh, in parallel, what is the element that is constant?
Voltage.
Voltage. Great. In series, what is the element that is constant?
Intensity.
Intensity. Ah, okay, look at this. In parallel, the voltage is constant. But what about the intensity? The intensity? Increase. Ah, okay, this is great. In some cases, I need more intensity. What is the other equivalent to intensity?
Amperes.
Amps is the unit, but it's more flow. more amount of electrons flowing for that point. What is the intensity in fluids, in hydraulics? The unit. Gallons per minute, gallons per hour. More gallons per minute through that point. In some cases, I need more flow. More flow of water, more flow of electricity. I need connect in parallel. I need more voltage at the beginning. I need connect in series. Depend of the situation, you need more volts at the beginning, or more amps during the day. I have a question. What about the house battery banks? The house battery bank, the service battery banks. How should be connected those batteries? In series or parallel? Excuse me? In parallel, because I need to collect the maximum amount of amps and deliver those amps during the day. A lot of amps. Oh, nice. How should be connected the batteries for cranking? Series, because I need a jump or high voltage at the beginning. How should be connected the batteries for bow thruster?
Series.
Series, because you need a jump for 10 seconds, and that's it. Oh, nice. Yeah? In some situations, I need more amps, parallel, or I need more volts, series. Simple. Difficult? That's not difficult. Okay. We are going to try to solve it. A couple of circuits in series and a couple of circuits in parallel. And I am going to show what is the secret to solve it easily, those circuits. The secret is basically try to think, that circuit is series. The most important that I need to remember in series is that the intensity is constant. If I found that the intensity in any of the points, I have the intensity in the rest of the circuit. In this one, in series, don't forget that the intensity is constant. The voltage goes up, and the resistance goes up. That's the magic part of those circuits. Okay, I have a question. Look, guys, I say that the total voltage is 12. I say that the intensity number 1 is 2 amps. 2 amps. And I say that the resistor number 3 is 10 ohms. I want to calculate the rest of the elements. This, the rest. Okay, what is the secret when you try to do those examples? Create a table. One table like this. Don't forget the table. The table is the magic key to solve those circuits. And I am going to copy total voltage, total intensity, total resistance, total power, and we are going to solve it. Voltage 1, intensity 1, resistance 1, power 1, voltage 2, intensity 2, resistor 2, and power 2. And the same with voltage 3, intensity 3, resistor 3, and power 3. Okay, what is the information that I have right now? I know the total voltage. How much is that?
12.
It's 12. What other information I know?
2 amps.
Intensity 1, 2 amps. And what other one?
The resistor.
Resistor number 3, 10 ohms. And I want to know the rest of the circuit. If you have the table, it's too simple. And if you know what circuit is series or is parallel? What type of circuit is this?
Series.
Is series. What is the magic key?
Intensity.
What is constant in series?
Intensity.
Excuse me?
Intensity.
Intensity. I know the intensity in any point?
Yes. Yes.
in the point number 1. What happened with the intensity in the other points?
It's the same.
It's the same. Ah, this is 2, this is 2, and this is 2. Remember that always, when I try to solve a circuit, I need to remember 2 magic formulas. The voltage is equal to, yes or not?
Yes.
And the power is equal to, with those 2 magic formulas, you solve it on this table. Okay, according with this, right now I have values in some parts. Can I complete the table right now with that information? No?
Yeah.
Yeah.
Okay, what happened with the total resistance? Oh, I know the voltage and I know the intensity. How much is the total resistance?
6.
Ah, it's 6. It's 6. Ah, nice. Excuse me. What about the total power?
24.
Is voltage times intensity. Is 24 watts. Ah, okay. What other point can I calculate? Ah, voltage number 3 is equal to 20. Power 3 is 40. Okay. What other point can I calculate right now? We are going to put, for example, 2 ohms here. What happened here with the voltage?
4 volts.
4.
It's 4 volts. 4 volts.
Then
Okay.
the power.
This is 4 volts.
Then the power is 12 watts.
And the power is
12 volts.
voltage times intensity. A.
Yeah, 8. Where the fuck?
8
is that
watts,
12?
no?
I'm tripping.
Okay. All right. And okay, good. And now, what about the total resistance? The total resistance is 6. The total resistance is 6. Is equal to resistor number 1 plus resistor number 2 plus 2 ohms. No? Okay. And what other information I have? Only the voltage number 3, the power. Probably I need information about other voltage, no? I need information about the voltage number 1. Is 3 volts. Okay, this is 3 volts. What about the resistor number 1? And now with that information I calculate this one. It's 1.5. 1.5. And now it's easy because I have 6 should be equal to 2 plus 1.1 plus
2.5?
plus 2.5. And now with this and this, 2.5 times 2 is equal to
5?
is 5. Okay, and the rest is easy. Is 3 times 2 is 6. And 5 times 2 is 10. And the table is complete. No? We are going to solve it other one. For parallel, we are going to do the same. Okay, suppose that in this particular case the total voltage is 20. And this is voltage 1 is equal to 6 volts. And intensity 1, resistor number 1. Voltage 2, intensity 2, resistor number 2. Voltage 3, intensity 3, resistor number 3. And suppose that the intensity number 2 is 1 amp. And suppose that the resistor number 3 is 2 ohms. We are going to try to solve it, the circuit. We are going to create the table. Okay, what information I have? Total voltage is 20. Intensity 2 is 1 amp. Voltage 1 is 6 volts. Oh no, sorry.
Power.
Resistor number 1 is 10 ohms. 10 ohms. And what other information I have? Resistor 3 is 2 ohms. Okay. We are going to check if with that information I can solve the rest of the circuit. This is a parallel circuit. What is the secret when it's parallel? Voltage is constant. Okay. What is the meaning of that?
All 20 volts.
And this is 20, no? Okay, great. And with that information, this
Wait.
one, no?
Yeah, there's still two. There's still two there.
This one is 2. And what about this?
That's 10.
10.
This is 10. And what about this?
10.
10, no?
Yeah.
10. What about the total?
14.
Look, what about the total?
14.
Is this plus this plus this is 14. And what about this? Is 20 divided by 14. How much is that? 1 point something, no?
1.42.
1.42. And yeah, you can calculate the power, no? You see, the secret is the table. With the table, you can advance. Difficult, my friends? Difficult? You need practice. Practice.